Okay, our next set of questions deal with the ABO blood types. And the ABO blood types, if you watch the other videos, are an example of codominance. There are two dominant alleles, capital IA and capital IB. They're codominant. The recessive allele is lowercase I. Individuals who are homozygous recessive have blood type O. Now, what is the probability that a couple whose blood types are AB and O will have a type A child, a type B child, a type AB child, and a type O child? So, we've got our couple. One of them is AB, so we know they have IA, IB as their alleles. If the other one's an O, they have to be recessive. So, we're going to draw our Punnett square. And we're going to put the AB blood type across the top. We're going to put the O down the side. And we're going to fill in our Punnett square. All right. So that's what we've got. And if we look, this individual is going to have type A blood. This individual will have type A blood, type B blood, type E blood. So we have 2 out of 4 IAI, which equals type A. And that will be 50% of their children will have type A blood. We've got 2 out of 4 B, I. So they will have type B blood, and that'll be 50% of their children. Type AB equals 0%. Type O will also be 0%. Now, we're going on to Jamie and Richard. Jamie's genotype is, Jamie is IAI. She has type A blood, but she's a heterozygote. Richard is IBI, also a heterozygote, just having a different dominant allele. So if we do our Punnett square, we want to find the probability of them having children with the different blood types. So if we go up here, we'll do Jamie, not right there, over here. And we'll do Richard. And we'll start filling in. Got so used to writing capitalized, I did it wrong. So, first child has capital IA, capital IB. Second one, capital IB, lowercase I, capital IA, lowercase I, and 2 lowercase i's. So, when we look at this, type AB, 1 out of 4, or 25% chance that their children will be a type AB blood type. Type B, well, that's this one. There's only 1 out of 4, or 25% probability their child will have type B blood. And of course, IAI is going to be A, type A, 1 out of 4, or 25% will have type A blood. And type O, again, 1 out of 4, or 25% chance their child will have type O blood. Okay. Now we're going to go here. Charlie has type O blood, and Joan has type A blood. Joan says Charlie is the father of her child, Carol Ann, who has type B blood. Is Charlie the father? Explain your answer. Well, this one we don't even have to do a Punnett square for. If the child has type B blood, and mom has type O, and mom has type A and dad has type O, there's no way for that child to inherit a dominant B gene. Because if Charlie had the gene for type B blood, he would be type B, not type O. If Joan carried the gene for type B blood, she would be AB. So there actually is 0% chance, because Charlie cannot pass on the gene for type B blood. Now, if Carol Ann was AB, there might be more if Joan was type AB, then it might be possible for Charlie to be the father. And this is actually, I took this from the history books. This is Charlie Chaplin and one of his mistresses. And he was actually the first person to try to use blood types to disprove paternity in a court case. But because the technology was so new, because back then blood typing and the genetics of blood typing was a fairly new field, the judge said that the procedure for determining blood types and whether or not that relates to paternity was not well proven enough. So he did end up paying child support for Carol Ann. Now, we're going to look at Fred and Marie again. So Fred has type O blood and Marie has type A blood. Their daughter has type O blood. What is Marie's genotype? Now again, we don't necessarily have to do a Punnett square to solve this one. If their daughter is type O, well then, she had to get a recessive allele from both her mother and her father, so that means Marie has that dominant allele giving her type A blood and a recessive allele that she gave to her daughter.